Hello, welcome back. So today I'm going to be continuing to work on Kano script. So it's gonna be another offline stream. Yeah, I'm gonna be doing another stream later today. But this is just an offline one because I just want to do something rather quickly. So I wanted to implement variable reassignment. So yesterday I implemented variables so you can assign them. But you can't change the value, right? So I would like to be able to do something like foo equals 15, and then it will exit with 15. And it should be pretty easy. We don't have to lex anything else. We just basically need to what we're gonna need to do is we're gonna need to use the in swap, right? So we're gonna push the value that we want. So push 15, right? And then we would in swap with the position where the variable is stored. So in this case, it'd be actually would be 1 at this point. So we'd swap with it. So that would replace the variable value with the what is on the top of the stack, and we'll bring that to the top, the old variable value, which then we'll just be able to pop and get rid of it. That's basically all that we need to do. Yeah, so it's gonna be like 20-30 minutes. So that's why I opted to not stream this. And then, yeah, and then I will be working on if statements later today on the stream. Okay, so let's see. Yeah, so we don't need any more tokens. It's really just in the parsing. So we're gonna need a few more things in there. Nothing with the expression though. We're just gonna need a different node type, right? So where is that? Where is the node type? So we have var. Let's rename it to var det, right? And then we'll have another one for var. Let's see. That's like variable declaration. This needs to be variable reassign, I guess. I don't know exactly how to call it, but I'll just call that for now. Type var reassign. Reassign. Okay. Okay. I messed it up. Sign. Okay, actually I think I need to spell it right. Also I'm gonna add a to-do here. To do change name type that to node that. Because that makes more sense. This type is more general, you know, and we don't have like namespaces, so you can't do like node type colon type var whatever. Yeah, so it's gonna be better if it's node prefix with that. Okay, so we have that, and I think that is about it, because then we just need the expert with it, and that can be the same as the type being variable, right? I believe. Yeah, because then we have the name, the type, and then this. Yeah, so we should be fine with that. So we just need to parse it now. So when we encounter a variable, we have two different things, right? Two different things. That's all the lexing. Soon I'm going to split this up into multiple different files, like a front-end and back-end file, and it'll be easier to go through it. But for now, I'm not going to do that. Okay, so, great operator. This is, alright, it's actually right here, I think. So parse. We want just the parse. Okay, right here. So we have the inet. So we need to look basically at the next one, right? So if, peak, is it token peak? And pass token there. If it is, if the next one is a colon, right? TP colon. Then we're gonna do all this stuff. So just grab this, and we're always gonna append the node, so I can leave that, I think. Okay, and we just we'll set initialize the node out here. Just zero initialize it. Okay, and get rid of all this stuff. Right for the that. We don't need this token consume there. Okay. Otherwise, let's make a variable for this. Token keep tokens. There we go. Then if token not type. Token not type equals that. And then we'll do else if token not type. So if it's followed by a colon, that means we're declaring it. So like this, right? Not that. Like that. But if it is followed by an equal sign, then that means we are reassigning, right? Equals tt equal. Then we have to do that. Else we're gonna print an error, right? So print error unexpected token that types token not type. Okay, just like that. So let's see. We might have to consume a token before we peek, but I'm not sure. So we're gonna do something like this. So we're gonna set node.type equals type var reassign. So I'm gonna rename that because that's not a very good name. This needs to be node.type as well. Okay, and then I guess the rest of it is pretty much the same, except we're not gonna expect all the tokens, right? So because really it's just the type that matters, because all the data is gonna be the same. Yeah, and then we're compiling it, we're doing something different, right? So node.value.var.name equals that, so that's still the same. And then the next one we're going to expect is the expression, so we don't actually need this stuff. We don't need the type, because we already have that. We don't even need to, we do have to set the name. Yeah. Set the name, we don't need to set the expression, though. No, we do need to set the expression, that is rather important. Yeah, so this. So we're expecting, we already have the TT equal. So I think we can just consume it, and then we're good to go. So then we can parse expression, and then we'll append it here. So I think that is pretty much it for the parsing. Let me make sure it compiles. It does not at all. First of all, this needs a node lock. Actually, it's not node lock. It's going to be token lock. Token dot location. Okay, and then an array. We expected the pointer. Okay, so we need to do something like that. Okay, to the arguments token peak. It also wanted peak by, so we're just gonna peak by 1. Is that right? That might be right. Okay. So I did integer but found equal. Okay. This is off, but it is gonna be online too. So let's look at that. So 1, 2. Just like this one. So did I mess this up? Got to peak by 0. I'm not sure. Oops. No. Unexpected token ident. So that's from this one probably. Yeah, so that is the identifier. So we do have to peak by 1. That was right. But then that breaks that. That's interesting. Token peak should not consume. So I don't know why it would do that. So we don't need to expect token here though, in this case. But I don't think that's the issue. So expected integer but found equal sign. Actually, that could be in here though. We have to consume it twice. Yes, that's what the issue was. Okay, so we have to consume it twice because, yeah, that makes sense actually. Yeah, so we have to skip over, because we know that there's the equal sign, but we have to skip over the ident and equal sign. So we do have to do this. So that's fine. So now it looks like it parses it, but it obviously doesn't compile it. So now we need to handle this type of our assign in the compile, right? The generate is what it's called. Generate. Okay, so let's have a case type var reassign with break then, and we need to do something like this, but not exactly. So we have the expert, but let's also print here. This is var reassign, and then this one is going to be deck large declaration. Okay. So we need to compile the expression, which is there. So that's fine. And then we don't have to update the stack position, but what we need to do is we need to do gen in swap, right? In swap. Well, actually, we have to check if the variable is in there already. So we need to get that actually. So we aren't going to do that, but we're going to do we have a function for that already? I think we do in the compile. So yeah, get variable location. So we can return the location of the variable. And if it's -1, then we have this. So we can grab pretty much the same thing right here and put it right in here. Let's see, that a little. Okay, get variable location. Expr value dot variable. That's not what we want. We want the variable name. So we can do node value dot var dot value. That's what we want. I think so. So get variable location, so that should give us the location, and then we want to actually in swap with that location. So we'll do gen in swap. I will give that's the state, the file, the and then the value, right? Which is index. I think that is right. Well, we need to do the state stack size minus the index, because we want that position. So I think that will work. Gen in swap. So let's go to gen in do. And let's make a new one for index swapping, right? Swap, and then this is going to be swap. Okay, and it iterates the stack size, and then we want to pop it off immediately. So let me make a pop, which can go right by the gen push. Oops, I messed that up. Whoops. Okay, so gen pop. And we don't need a value for pop, we're just gonna pop, right? So call pop. And decrement stack size. Just like that. And then when we call gen install, then we need to call gen pop state file and nothing else. Okay, so let's see if that compiles at all. It's not indeed. Yeah, so we don't have this. We need the node value.var. Okay. Build it. Okay. Print error. That's a pointer. You need to use arrow. Why is it a pointer? Oh shoot, we don't want the value, we want the name. Yeah. Okay. So that compiles actually, and let's try to run it on Kano. Let's look at the generated TASM. So do we have in swap? We do. So variable reassign. Expert, so here's the expert, in swap 1. And then we pop it off. So let me just keep track of the stack here and make sure it's right, and then we'll actually try to execute it. So we push, we have this, and this ends up with nothing on the stack, so we're good with that. Then we push 12 and 5, so int and int. We add, so that removes them both, and then pushes a new one. And then we push 7, and we do the same thing, so we end up with 1 on the top of the stack. And then we push 15, there's another int, and we swap 1. So that's going to be not the top one, but this one. So it swaps these two, essentially. So that's exactly what we wanted. Okay, so it swaps those two, basically. And then we pop off this one. So then we have 1 on the stack. See, but then we have this indupe 1, and I don't think that's right. Because we don't have any other values on the stack. It should be indupe 0. So that's going to be out of bounds, if I'm not mistaken. Build slash TASM, build slash tired, index out of range, exactly as I thought. So, where did we go wrong? The pop, index swap, the swap does not increment the stack. That is the issue. Okay. Yeah. We don't want to increment the stack because it does not push anything new. It just swaps two things. So we need to do that. And then we don't need the state in here at all. Okay. And swap and get rid of the state. Okay. Makes things easier. Build that. And let's try to compile it now. And that looks better. So now we have the 0 here. And this is still 1. So let's try to actually compile it. And it should hopefully work. Build that. And we have 15. So that is right, and if we make it 15 plus 5, so it should exit with 20, right? Whoops. Volcano. Build client, and 20. There we go. Okay, so let me just add a few more tests. So let's define another variable here. So this should just be x int equals foo. Let's actually do it like this. Ooh. Okay, yeah, this should be equal to the original value of foo, if I'm not mistaken. So if we exit with foo, it should be 20, and if we exit with x, then it should be, what is this, 24? Is that right? Yeah, 24. Let's try it. So it should be 20 this time. Okay. And if you exit with x, and go through the build steps here. 24. Okay, there we go. I just want to make sure it wasn't like a reference to it. And by that I mean it just points to the same one. But I remember how it works, so I thought it would work. Yeah, I was quite sure, and it did work. So happy about that. So I'm gonna commit this, and then I'm going to just go through and clean some stuff up. And then, yeah, that's gonna be it. So that's why I wasn't streaming this, because it's been 15 minutes. And it's pretty much done. So. Variable reassignment. Okay, so push that. Okay, so let's see, what can we look at here? So these obviously have quite a bit in common. So we compile an expression. We set it at the stack size, so that's probably all fine actually. And if we reference variable that does not exist, we should get an error. So if we do like that, then it should error. And it does. Okay. So obviously the location is not quite right. I have a few issues with that, so I might just fix that really quickly actually, because that would be pretty easy. At least part of it. So an issue that we have is where we're keeping track of the column is not ideal. Let me just search for the Lex function. Okay. We're keeping track of the column by we start the start point, and then we subtract the current position, or the current position minus the start. Now we're starting for the first line. Once you go to a new line, it has to be reset. So I'm going to actually just introduce a column here and just increment it. Like literally every iteration. So here we'll do column plus plus, and here we want to set column equals 1. That should pretty much fix that. So anytime that we set the location, yeah, we need to change all of these with column. Column. Quite a few, and I don't have like a good way to query replace a lot of things, so I just have to do it manually. Column, okay. And then we have, do we set the column up here? Right up here. Maybe we could even initialize the token outside of this loop. You know what I'm saying? That could even work. Then we don't have to say it each time. Like we put it at the start of each loop. Because we can just initialize the token and then get rid of it. And that's fine, you know? I might change that as well after I get this working. So I just want to make sure it works, and then I will try that out. That's not going to fix the one error that we looked at, but it is going to fix some of the other errors. So, alright, so let's build that. And unvariable start. So we don't need that anymore. An alternative way we could have done that is by just incrementing the start as well. Each time we reach a new line, but I feel like this is maybe even a bit easier. Alright, so we still have that, but let me try to have an Alexing error, right? Exits. I think that will give us an error, right? Maybe not. Okay, so that doesn't work. There's one that I could do. Let's do that actually. There you go. And 2, 7. Okay, and that should be 2, 7, right? So 2, 7. Okay, it's pretty close. It's pretty much right. It's close enough. Like, as long as you're in a general area, then it's fine. It's at least decently close. You know what? Every time we increment this as well, we need to increment this. That's why it's not completely correct. Ooh, okay. Yeah, I forgot about that. So, you know what? I am gonna change that. So, start equals data. And then, yeah. Alright, so I'm gonna change it all back. But I'm gonna update it. So, instead of incrementing it here, we'll set start equals u.data. And that's going to basically do the same thing. But now I have to do all this again. So we have to, yeah, I didn't think that through, but this should be better. So let's, we'll take the u.data minus start. Like the current position minus start. Data minus start. And then it should be more correct. Like the other way, it would be a bit harder to get it correct. So that's why I'm doing this. And this should be like correct every time, you know? Data minus start. And then I'll go through and try to refactor this, and then that'll probably be the end of the video because, yeah, didn't want it to be too long today. Okay, this should be the last one. Alright, let's try to compile that, and then run it. That did not work. Okay. Why did that not work? Does not equal 0. What? So this assertion failed when we call token consume. Why did that happen? Why would this have anything to do with that? If I get rid of this, then it doesn't fail like that. It still does. Okay, so I messed something else up. Where did I do that? Did I accidentally subtract from that? Like the actual value of it? Perhaps, GDB, and we can see just where it breaks, you know? And then run, and can we see the file, or the location that it breaks on? That's not very helpful. Okay, break on main, it's gonna be in the parse, so. Actually, let's break on token consume. And we'll just go through all the instances of that. Okay, so let's print tokens. Is 22, so that's all good. So we're going to call that again a few times. And we're just going through the whole thing. Okay. We'll continue. Let's display tokens count. We can see. Display tokens count. Continue. Alright, so we'll go through, and then it gets to 1. And we'll step through. Tokens count is 0. And then where are we? So let's print the parse native node. Okay. Oh shoot, so it's not failing. Wait, what happened? What happened? What happened to break this? I don't know what what? So it's in the native node. Let's click on that again. Let me try to do it again. So that's going to be on the exit one, I suppose. Break native node. Run. Oh shoot, run with interact. Alright, let's print node. Or print actually tokens data 0. So this is the right one, so I think we get through this one fine. Let's continue to the next one. So let's next, and this is should be it. So let's print tokens data 0. Let's print tokens. Count. What is it? So it's 1 right now. Okay, that's interesting. So the value is type. So it looks like it is an exit node. Okay. So that's what we're on, and we don't have anything after that. Quit out of this, yes. Oh shoot, because we don't have anything after that. So we need to check that when we're parsing it. So we should token consume. Want to expect the token. So why don't we do that? That's kind of important. So instead of this, let's just expect token here. So it could be an integer or an identifier. So actually, I'm gonna say token equals token. Does that return it? Does token consume return the token? So, let's see, it should. It does, yes. Okay, so we can use that. So that's gonna return the token. And then we can do if token.type does not equal token type int, and token.type does not equal token type int. Then we will just print error token.lock expected int or item, but found this, and we found token type token.type. Okay, and you can see what it was. Alright. And we should be able to do the same thing down here, but we only want to expect a string. Actually, switch over to the type. Where's the type? Huh? Wait, hang on. The type of what? Type that we pass. Wait, that is interesting. Oh yeah. Okay. Yeah, I see. Expected string. String, but found that. And then this is pt string. That should be it. So I think that still works. That's just the type that we pass, the type that we're expecting, right? Let's put out that and build it. token is unpaired. Why? Oh, because we need to do this. Let's actually do that up here. Build it, and try to run it. Picked string, but found right. Okay. What? Yeah, because we need to consume and then do that. Searching failed, unreachable. Huh. That's not good. 673. Shoot. Why does it do this? That's not good. Alright, we have big issues here. It's going on longer than I thought. We consume it, and that's the last token. So the data size is now 0. So I don't really like the way I can token consume. Let's do token equals data 1. Let's see if tokens count. It's less than 2. Wait, so we need, yeah, we need 2. Then want to print error token.lock. We don't have a token lock. We can set it to node lock though. Error. I'm just gonna do that for now. Error %s. Let me just pass the node types. Node dot type. Just temporary error. I just want to see if that works. Type string that. What? And let's print the token types. Token dot type. Let me see what that is. String. Okay, so it is string. And then when we go in here, we should have a string. Wait. Then we can call token consume. For both of these. Error, native. Okay, so that doesn't work. Which native is it though? 318 though. Okay, so we're on 318. So that is like 3. What? What the heck? I don't know what's happening. Alright, let me go back to how it was before. When it actually worked. At least somewhat. Let's count this out. What it is. And we need this token consume. And the assertion fails. What? Wait, why? Oh shoot, yeah, because it is broken. So that is why it doesn't work. So then this expect token, does that work? Get rid of this. Let's get rid of all these, and let's just do that. Like an integer, but found it. Okay. And if we change this back to exit 15, it should work. Okay. And if we do foo equals 12, and then foo equals 15, and we exit with foo, then it should all work. Nope. I did integer, but found ident. Oh shoot, so this, that breaks, yeah, so that breaks it. So it has to be one of those types. Yeah, so we can't just expect token like that. So that's what the issue is. And let's re-implement it back up. Not completely, but just in this function for now, please. Expect token. Okay, yeah, so it just consumes the token and then it checks the next type. Okay, we can do that. So what we need to token consume, and then we need to just check the type of the next one. So this should work. Why does it become unreachable? I don't quite get that. Let's just set it to the top token. Tokens, data, 0. Then it works. Okay. Volcano, and if I get rid of this, it should not occur. Okay, there we go. That is it. So, yeah, I think I see what happened. So I need to really refactor the token consume and expect token, because they don't really work how I would expect. Yeah, so I'm gonna do that. That'll be like an option kind of thing, though, because it's kind of boring. But that's pretty much about it. So let me commit this. It's a fixed issue with maybe nodes. Alright, so I will push it. Yeah, it's not a very big change, but there we go. So that's gonna be it. Yeah, so I'll see you guys next time.